come in late or don't make it. Just a second. Okay, well, with that, I will go ahead and hand it off. I'll help kind of watch for hands as well throughout if you can't see them during your presentation, and call them out if I see them. So go ahead and give you the floor.
Yeah, thank you, JT. Thank you for having me here. Thank you for hosting the call. Really looking forward to presenting much about the Terminus DB data product model and what we've done with it at DFRNT. So I'll be sharing first a little bit of a presentation, and then I'll be going through a little bit of a demo so that we can have a free conversation around how this data model works and the relationship with the knowledge graph world in general. And please interrupt me for any questions as you have them, for clarifications, etc. As for me, I have a background 25 years being a solution architect, digital architect, and been working with a lot of data. And I've had a specific pain point not really being able to properly model things, and so I'm solving my own pain point with this product. So I'll be starting a bit of sharing about DFRNT. And we think that we're made for change makers. So it's really the people, the crazy ones, the people that make change in the world. And we believe there is a special place for making a lot of change. And the product is built for digital architects to have a default useful location to perform data modeling, really, for any initiatives that come that way and to build upon them over the long term. And for me, I've been missing really that early prototyping stage to be able to quickly draw up a data model and to be able to do something with it. So what we're doing at the moment is really to enable digital architects with trusted project for expressing semantically structured knowledge and enabling that hope for tomorrow to build a data world that is actually modeled, it is structured, it's not free for all, it's actually a constrained proper data set in many of the instances where it's not today. So why this? I shared a little bit of that background, but as a solution architect in the beginning of initiatives, I have always been in large enterprises. We've had the issue that we couldn't always share with the vendors that came in that we were looking at their products. So we wanted the ability to start to scaffold an early data model for what we were building for a capability that we were implemented in enterprise. We had to look at the data that we had and also what this new capability would enable us to have so that we could look at the different data parts really and the model for it. And it didn't have a good tool to visualize the data, so it was down to PowerPoint, Excel files, writing down into Word documents, but really missing that ability to have the model, the data, and everything connected together in a way that I could iterate upon the result and have those 4 and 5 iterations until we came to something really good and explore together with vendors how it might look in the future. So that was the pain point I wanted to solve for. So 2 years ago, I started building this tool because 20 years ago, I saw RDF. I wanted to do something with it. It wasn't really what I wanted at that point. 10 years later, I needed it. 10 years down, and that was in 2020. I figured if no one is building what I want, let's get it built. And that is how I started. So knowledge graphs and doing that in data products, that is really what Terminus DB does. I don't know how the experience is with Terminus DB. How many know Terminus DB? Is that new for many of you? Hard to see. I can only see one person at a time. So I'll go a little bit into the detail of Terminus DB and a little bit of what it is. So imagine an enterprise, you have master data. And that master data is usually constrained by a model so that it has a fixed shape and you can have a firm expectation of what you have in your master data. That master data sits usually in some located in a central location so that everyone in the enterprise in the different silos can share that data for the different parts of the enterprise. And if we look at an instance, locally in a silo, you may have then an instance data model with your local data. It could be sales and marketing data, it could be customer services data, the supply chain data, or something else. And if you look at another instance, this would be customer service maybe, and the other one sales and marketing. you would have your local data there as well. You have local autonomy in general for that data, but you need to follow the structure of the master data and to have the master data locally. So how we usually do this in the enterprise is that we co-locate the master data, a copy locally that we get updated along with time, or we have APIs that connect to the central location. But we don't really have that separation in a good way and the collaboration, and that is where the GitHub-like collaboration for changes introduced by Terminus DB is. And by enabling this way of using data products and spread them out into the enterprise and having knowledge graphs in them, you're able to have this local domain-bound knowledge graph. And I believe that is an important consideration to make, because you will face scalability limits for the knowledge graph in terms of performance and other things, and having rather the local smaller parts of the cake at once, you're able to do much more efficient processing over the smaller data chunks that you have, and you can still share the schema. One thing that is important for me when building different is to cross the worlds of and to enable a bridge between the world of software engineering and the knowledge world of ontologies, taxonomies, data definitions. I believe that there is a little bit of a divide between the two, and in my view, there's a lot of things missing in that space that should have been there. So I'm talking a lot about Terminus DB because that is the data model that we're building different upon. So the domain-bound knowledge graphs, I use a term of the boundary objects, which is, think of a map. That is something that can be shared by multiple people, and it's plastic enough to make sure that it can cover many use cases, but it's also structured enough to enable the collaboration that is needed in a certain point. And I think that digital boundary object is the digital form of that, and I think that data products enable that way of thinking. So the boundaries enable data product composition. What do I mean with that? That means that we can take multiple data products, and those data products we can compose together to do analytics on a specific piece of the larger pie. And for data iteration, I believe that the collaboration model for code should be there for data as well. You should be able to define a change set, branching, test things, and simulate the future of your model or for the instance data in a branch, in your QA or in your development environment, so that you can test out new ways of modeling your data without affecting production, but also have it as a controlled subset, as a controlled change that you can then bring back into the main branch. And these are some very elegant properties of Terminus DB that we really, really liked. As a model, it is a closed world model of knowledge graphs, so the RDF in a closed world fashion, which is a model that we find is relevant for the enterprise and cross-organizational use. We can talk a little bit about Shackle and OWL as well. I'm not the expert in that area, but it's closer to using Shackle for constraining OWL, which is more open world. And I'm writing a paper as well together with the Terminus DB guys a little bit around trying to expose exactly what is in the different parts for that. And what they add as well is a graph data log engine with path queries so that you can look into your graph. You can take all of the points in a graph and you can ask and query and reason about the data in it. And also use GraphQL for exploration of your data. And we will be looking at these things and how it looks in a graphical user interface, because different is a user interface on top of Terminus DB. And when I presented to the semantic arts team, it was a bit of confusion as well as what is different, what is Terminus DB. Everything that you do in different is really a user interface on top of the Terminus DB constructs. It was a lot of things at once. Any clarification before we move on to the next part? There will be more. So if we go into contextual data products, so we have this bounded data set as a data product, which means that we have many of these, but we have one or more schemas. And we share a context metadata around the data products. We can see it as a boundary around the data that we have and a specific model for it. So you have one schema graph and one instance graph in that data product, and it becomes a composable unit and one specific unit of collaboration. So I call this a unified schema. So it's stored with the data, and it's an adjacent graph, so you have it co-located. And you have a core ontology that you can build up out of one or more upper level ontologies, such as GIST. And you put that into a unified schema that constrains your data set. So you have very clear definitions for all of your data that is there. And when I'm talking about the data, I'm thinking of triples and knowledge graphs. And there is a specific way in terms of DB using the JSON LD documents that we'll come back to, that is the expression of these triples. And the data product, unit of distribution collaboration, as said. So in Terminus DB, instead of using turtle files, you can use turtle files, but more in the lower layers of Terminus DB. But the main thing is to use JSON linked data, which means you have a document-oriented presentation of the triples that are in the database. And so the unit of collaboration is a JSON LD document with all of the triples connected to them. But you don't store it as a document, you store it in the RDF graph. So all of these triples are connected together as documents and the data structures that are there. So we'll look into an overview of what that looks like as well. So when we have all of these properties together, we have a question from someone there.
Yeah.
Is there a relationship between a shape and a document?
Please repeat. It was a bit of noise. So
is there a relationship between a shape, a shackle shape, and a document?
We are not using shackle here, but the Terminus DB schema is similar to the shackle constraints. And so yes, for the data, you would be able to constrain it to say that you have a cardinality, or you're saying that it can only be a string, or it can only be something else. And so you need to have a certain shape on the data that is according to the schema that is defined. I don't know if that helps to clarify.
Well, it's okay. It sounds like there's in many cases, if not all, there's a one-to-one relationship between a JSON LD document and some sort of shape defined by some sort of tooling.
Exactly. Yeah. And so here you have classes that are defined as well as triple that constrain the JSON LD document so that it can only have the certain form that it should have. But we'll come back to that. I think it will be clarified in the next page. So coming back to the idea there that what you want is really to be able to have the ability to build software and to make use of the data in various shapes and forms. And you want a one source of truth for the model so that we can use the same model and have that. This is the model. This is how it enables data, and you enable the collaboration between software and the knowledge world. So these documents, in different, we also built a model on top of that with the JSON schema that enables you to check that the validity of the JSON LD documents, that they are valid outside of the Terminus DB system as well. If you have an input tool or something like that, that you need to make sure that the data is correct way before you enter it into the Terminus DB data store. So here we can look at a type, an enterprise risk statement. And if we look at that enterprise risk statement, we can see that we have inheritance, and what we have here is not an ontology. This is how we build up the enterprise risk statement that is on top here. So we have a number of properties that are inherited through the hierarchy, and we also define some of the elements as data structures that are composable or reusable. So if we look at entity, which is down on the left, we can see that label that is defined on entity, we can define it in any way we want, but this is an example. We have a label that is inherited up to statement, and that is inherited into enterprise record and the types, and it's inherited into the enterprise risk statement. So all of these rhomboids are in the representation inherited. We have multiple inheritance so that we can, for instance, have the content tag from tagged record to inherit into the enterprise record and up to the enterprise risk statement. And the model in Terminus DB also allows data composition so that you can you reuse data structures across. So it's a layered JSON LD. So each layer of the JSON, you can see it as object. So each layer is defined by a data structure. And that data structure is a class, and the class definition defines properties, and you define how you want to aggregate other data structures into your full type. So we can look at that a bit more in detail with a simpler example, with a CMS example, where we'll only look at the specific things that we can recognize from the CMS world that I think that most of us have seen. So that would conclude the quick overview. I could show a little bit. So M. Sullivan, if you want, we could look a little bit about Shackle, OWL, and the comparison with Terminus DB, if that is interesting, or we go directly to look at the tool. So it's a bit of a cross fork.
Maybe just straight to the tool, and then we can circle back.
Yeah, absolutely. Oh, yeah, the architecture. This is a bit of the roundup as well for what is in there. So basically the closed world model that I talked about. And then we have the layered JSON LD, which is basically the RDF triples that are there. And the document type model with documents, sub-documents, which are really the documents that constrain triple on these layers, and enumerations. Terminus DB exposes GraphQL API, the WACL data log SDK, and the JSON LD document API. And what we like a lot is this GitHub-like data collaboration, which enables branching. It enables the ability to push and pull data from, for instance, from your laptop up into a cloud instance, and the back and forth, so that you can also have cherry picking of changes that you want to bring back to your main branch. So we build on top of that with the data modeler. So we have a schema editor, so you can edit the schema visually. You can edit the data, so you have form-based editing, and you also have constrained editing of your JSON, and or you've used YAML. You can navigate the graph data. Data visualization, a bit of Canvas, and this is something that we want to work a lot with to really enable the visualization aspects and ability to explore the triples as in the GraphQL interface. And of course, then to be able to administrate the data products that you have as part of your instances. So summary, user interface for Terminus DB data products, a data product builder for semantic knowledge graphs, and the visual interface for it. And this ability to have kind of a semantic spreadsheet, but it's not a spreadsheet, but it's that unit of collaboration. So let's go into the demo. So this is different. So you come into main page, and you see your data products. And so we'll actually be looking at the different homepage. So the different homepage actually uses a data product beneath to render all of the blog posts, etc. So I think that is a way we could look at it. So I'll start with a familiar view, an ontology view that is rendered from the type. So we're in the type model. So here you have a hierarchy of types. And I hope in the future to actually be able to have gist as part of the schema template library, so that you can directly incorporate some of the gist types if you want to, so that you can use those directly. So here, let's take blog post, markdown web page. We can take category. Person is interesting. We recognize that, a web category. And traits, they're really the data structures. So let's add a few of those as well to our visualization that we're building. Markdown, front matter, and we can have an ontology view of this. So we can see that we have an author for a blog post is a person. We have a markdown web page has an author, so that we can look at an ontology view. And if we then look at a class diagram, you can see the same data in a more data-oriented fashion, where you can see that we have inheritance didn't actually add anything that they would inherit from. So let's add a bit more in there, and entity as well. And so you can see the inheritance of your model. So when you built your model, you can see all of the things and how they connect together. And you can also hide the stuff that is irrelevant. So when you're using this, you can copy out something called a mermaid diagram. If you're not using Mermaid already to document your data or the classes, etc., or state diagrams, I really can recommend to look in that. And you can copy diagram definitions as well from here, so you have a natural way to build them. So if we then look at something that we built, so we can look at font matter, which is defining a web page. We can have a definition for that, and we can see the same kind of structure that we had previously, where you have all of the properties and what they link for and the additional data structures like person that it's linking to, and it's composing the Open Graph metadata. So when you edit, you can edit, of course, the schema, and then you have a form-based editing of a property with a description, with the multiplicity of what you can have in your instance data, the type of property, and if you're linking records or if you're composing in so that you're taking a trait, a data structure that you're attaching to this record so that you can build a hierarchy of records, which means that if you're thinking of a regular tabular data, you would actually have depth in each of these columns, which is a way of thinking about it in terms of the knowledge graph. And you would be able to define it the same way using JSON or YAML so that you can look at your data and edit the types and data directly. And with that, if we take if we want to create a blog post, it takes the forms that you have in it. So this is based on the, oh, sorry, now we're editing the data. Let's add a blog post instead. Let's go into blog post and add one. So we will get the same structure. So you can actually have a form-based entry of your data with definitions and JSON data. So you choose how you want to enter data and update it. So going back a little bit to something else, we can look at a risk assessment. So if you look at risks for a company, the example we had previously, we can look at a company and how, and if we render out something with a graphical canvas, we can look at instance data. Now we're in the instance data part and having a graph with cybersecurity risks, which might be more interesting because you have a lot of fields in a cybersecurity risk. So if we look at the enterprise risk statement, that is the definition we had previously. So we have enterprise risk statement. And if we look at one of these, we can render out the data itself. So this is not a document like Markdown or something. This is actual data that is typed so that you can surf around in your data and look at the data that you have in your data product. So if we look at this specific statement, we see it's owned by Michael Johnson, who is the CEO and part of operation, and he has a few other risks that are there, so we can go around to those. And if we want to take something, we can just take everything that we have, for instance, in entity, and take all of the things that were there. We add them to select the page items, the things that we have there, and just graph them up. So you can take any data and you graph it up if you want a visual representation of what is in your graph. So that would be a quick overview. We can see that we have the branching. So if we want to, we have the main branch here of the risk assessment simulation, and we can easily create another branch to work with, my extra branch. And you create that branch. And what you do within this branch then is that you can have edits that are separate. So you have multiple versions and multiple views of your data product. So you can edit the specific branch and work with only that one. So you manage branch, you add a branch pointer, and then you're changing to that branch pointer, and you can update the data in it without affecting any other data that is there, which means you can do some experimentation and simulation so that, and in the data, you can then rebase or merge with the main branch. So you can take your edits So if we go, so this is in the main branch, so we can merge from the my extra branch once we're done with the changes, and we can take all of those changes and pull them into the main branch so that we can continue working from there if the experiment was successful, or we can just delete the branch if it was not a successful experiment. So you have the full history as well for all of the edits, which means that you can also go back in history and say that I want to reset my branch to this location, and then suddenly all of that new data that you added will be gone, which can sometimes be advantageous and sometimes not. For those that are familiar with GraphQL, so we've been talking about the JSON LD documents. So these are technical documents, and they contain all of the triples as part of the structure. When you want to go into the core of the knowledge store and use the triples and look at them, you now have a constrained model. So we can go for enterprise restatement, and we can take responsible person. So now we're going over into the person object, and we can take label. So when we want to do queries, we can query the database the way we want. So we can take record department, and we can take a label from there as well. And it helps you to find the data based on the structure and do queries directly on the database to find the data in the way and the shape and the form that you want to. So when you're using GraphQL from other systems, this enables you to more quickly find exactly the data that you need without taking more data or less data than is required for the use case.
There was a question in the chat on that
Yes.
last one. What is meant by optimize a branch option?
Yes. So if we go into the branches, so this is the specific one. So optimize a branch. So the data structures in Terminus DB, they are in layers, and there is an optimization layer on top. So it will take sometimes you need to optimize the branches, especially if you're working on the local computer. In the cloud, it's done automatically for you, but you will have the data will be spread across multiple layers. So if you want to go really fast, or you've done a lot of edits in many layers, so you have a lot of layers, you will need to optimize, and then you will have a cached version of all of the elements that are further down in the layers. Does that help answer the question?
Yeah, that's fine.
I think that's good. Yep.
All right. So I think this is more or less the quick tour. We have looked at branch pointers and the other parts and the multiple pointers to different parts of data products. And if we just quickly look into, you have API and API keys that you can generate. You can work with your instances. So for instance, Rusty Gears Inc., which is my pet fictitious company. There are a number of data products, and you can clone data products there. So you can clone between the instances and move your data products around. So yeah, I would say that is the quick overview before we go into a bit more of exploration together for the things that you would like to look more into and are curious about.
I don't see any hands. Did you want to go back to the shackle one you were mentioning there?
Yeah, we could take that quick overview. So there we go. So I was looking a little bit at the differences between the Terminus DB schema, unified schema that they have, and how this looks in the OWL and shackle world. So you would have OWL that defines your shape, and my understanding is that you can do some of that in shackle as well, so that you can use shackle. But you would use OWL and shackle together to constrain your data and have a specific definition for it. And the collaboration, from how I understand it mostly is done, is that you either have a triple store that is a huge one single specific triple store for most of the data. And if you have multiple locations for it, it becomes fairly hard to get all of that to work together. Much of the collaboration with the definition for your data is in turtle files that are often handled as Git or as code in a Git repository. So with Terminus DB, the difference there would be that you would be using their schema definition that is close to how OWL and shackle works, but with their specific quirks and that they find advantageous. and you have the Git for data collaboration model as a benefit for the specific schema. And all of it is triple based. So you get a document orientated view of the triples. So you can have a RESTful interface, or there is a RESTful interface so that you can push a JSON LD document and all of the triples will be updated for you. So when you do an update, that is the single unit of representation for the triples, which is much easier in many cases to work with.
Michael's got his hand up again.
Do you have any inferencing going on? I assume maybe it's backward chaining instead of forward chaining.
That would be a level of details that I don't have everything, all the knowledge around in terms of the Terminus DB basics. That is different company. They know their stuff the best. There is a bit of inferencing done on the schema level. So if you push, for instance, a JSON document, it will discover what kind of a document that is, so that you can actually find a schema for that document and store the triples according to it. And as for the data log engine, the Terminus DB, it's good to know that the Terminus DB is built upon Prolog at the core, and the data log is a subset of the Prolog engine capability, exposed as a with their SDK for JavaScript and for Python, so that you use Python expressions, and over the wire, it's a JSON format for it.
Chris.
So, sorry, this is a sort of slightly different branch. So if somebody wanted to pursue that previous branch, then they might want to get in front of me. But you went through quite a lot of stuff at quite a high level quite quickly. If we can go back to something you said quite early on, if I remember rightly, you defined a data product as having basically two graphs in it, one of which I think was the schema and one of which was the data. And you said that this was a great basis for data integration, which on the face of it, I would think was an excellent thought. But I wondered if you could go into a little more depth as to actually how that works.
So more or less on this picture, if we look at this picture,
yes,
this is the one you're thinking of. Yes. So and I should take a little bit of background on that. So the reason I'm thinking in these terms is that I am thinking fairly far beyond a single enterprise or a single organization. So I think of cross-organizational collaboration. And in cross-organizational settings, you have the issue of data. It needs to be owned by someone. So where do you host the data? Do you have it in one organization or the other? And that is the advantageous thing with how we did with the GitHub collaboration model. It can live in both places, and we can collaborate with on the changes, both of us. So we can create a change.
So when you say live in both places, do you mean copies of the data, or do you mean links?
No, so it's actually a copy. How should I express it? A controlled copy, so that you have references within each data product. So you have data structures that are stored in both locations, but they have references and referential integrity to check what happened and what was the difference from the previous version, thanks to the history, so that you can reconcile the changes of one end or the other into a cohesive unit that works. So that you can do push and pull like you do with code, and then you apply a change set on the other database so that you can follow one another. And that is also a way to propose a change that you push back and say, hey, I did this change in this branch, and I would like to integrate it into the main branch of our data. Whether you do it for a model or for the instance data, you can actually do both. Okay. I don't know if it answers your answer, but yeah.
From a data integration point of view, if you think about the schema graphs in the two data products, presumably you have to compare those schema graphs and work out how they relate to each other. How do you do that?
So you have a master. So if we imagine that we would have we would like to have a shared schema. Okay. You would have a third one, and then you push and pull from that one, or you push and pull between the two ones that should have a collaboratively updated schema. Okay. So you would push and pull between
you would have a designer of some kind sitting there and working out that overall master schema by looking at the two that need to be integrated.
Yeah. So, and it depends on how you want to go about it. You have many options in here. You could also just move over and copy over the schema definitions and have those as one single setup, so that you actually move the schema definition over to the other database and put it in. That is also an opportunity that is quite simple and easy to do, but it wouldn't give you the same advantages of actually knowing exactly the precise changes that were done.
Right. I was wondering if there was anything on the semantic side in terms of using ontologies to relate those schemas to each other.
No, that would more be of the data representation of the schema, so that you would get, so you don't naturally query those changes, but you can go actually and use the data log engine to query the changes specifically. So you can ask, what was the difference between these two layers for this branch, and what changed between them, so that you can do intelligence analysis of what happened over history as well, because all of the layers are also exposed as triples.
Okay. I mean, I don't want to take us too far down here, because I'm
You're
aware
welcome.
it's a somewhat specialized path that I'm trying to follow.
Indeed. But you're welcome to reach out as well after the call. We could have a call going in detail. But I think that if we go much further than that, I think the Terminus DB guys would be better to answer it. They're a great
Okay, so
Discord
this
for
is
any questions.
the Terminus DB layer, but your layer, I presume, would give you interfaces to what's happening there,
It's a
and
user
some
interface
kind
on
of
top.
ability to control it. Yep. Okay.
Yeah. So I don't go into all of the technical details. They are master at the craft. And so for me, it's really about exposing a user interface to solve my pains with it. Not with their product, but my pains of actually building models in the way I'd like.
Okay. I mean, if no one else has questions, I can ask some more. But
Sure.
so I mean, when you say you give people help in building these models, do you use ontologies as the basis of the semantics for their defining those models, or some other way?
Here is actually, I'm not working directly with them. I'm only offering the service for it. So I've done some data modeling, but it's mostly on my own. So I
Okay.
have some thoughts of opening up. I'm very new. So we launched in January. So this is a very new product in general. But we're thinking over the summer to have a few open sessions for collaborative modeling using the product to learn together. There are a few first customers, and they're using it effectively for their modeling domains and for modeling Terminus DB. So the main people that are using it today, they know Terminus DB out and in, and they're using this to simplify their work and to work it that way.
Okay.
And for me, what I'm helping my clients at some points to model things, but I haven't done that advanced modeling yet. I haven't had the need. So it's more to visualize data. That is what I've had as one of the main use cases at the moment, to visualize how the models are working together. A few enterprise initiatives that are starting up that I'm actually helping to visualize a little bit on the future data model and how it might work.
And you're using GraphQL as one of these visualization techniques.
Yeah, the visualization, not so much with the GraphQL, but rather with the dependency graph visualizer that I have in it, that can show the automatic dependency graph, so that it's not a tree, it's a graph, so that you can see how the things interrelate and to really put them in a line together, because that is something I've had a huge pain of finding a good way of expressing.
Yeah, I mean, my impression of GraphQL was it was a great way of making a relational database look like a graph database, but not all that much good beyond that. I don't know how you feel about that.
I would say that it's a great way to actually expose triples to the world, and I would say that it's one way you could use GraphQL for exposing more or less any graph-oriented data, but here you would be able to actually navigate the entire graph. So you can go down. So for instance, you have enterprise restatement here, and then you have person that is a different object altogether,
Right.
and you connect them together as part of the triples.
But if you're using triples, it's less powerful than Sparkle, for example.
That is where you would use the WACL interface, where you have path queries, you have the ability to, and you also have some of the path queries here so that you can, I think it's path to risk. So you can actually search for path to person instead. And on person, you would have labels. So whatever ways we can find a person, I think I need to constrain it. So I don't have it in my head exactly how that is done at the moment. So I think it's path. You write an expression, and using that expression, it will find a graph path in the database to find the relationship between enterprise risk statement and person, even if there are multiple paths that it needs to cross in between. And I think that is something that is fairly hard to do in Sparkle in many of the instances, even though many of the vendors put this into the Sparkle engines so that you can use it.
Okay.
And so what I've done is usually I create a model, I go in, let's say we have entity agent, let's say we add a few people, that won't help us that much. So let's statement, enterprise. So let's take the enterprise risk statement. So I would be adding many records. So I would add a table of data that is interconnected. And so that comes maybe from Excel. I just make a model out of it and just import it so that I can get a canvas out of it. So I can have this kind of an expression of the dependencies between things and automatically rendered. So I don't have to do the rendering pipeline for it.
Okay. Sorry, I don't know if
Yeah.
I see my hand is still raised, but just from when I first asked. I mean, thank you. As you can tell, I'm quite interested in your system. It's doing a lot of things which are sort of on the face of it similar to some of the things that I'm doing. So that's why I'm interested.
Nice to hear. And for me, as I said, I'd like to go into the GIST route, but I haven't gone down that path yet. I've been building the system. That was the first priority, getting something that could support it. The next step is to look at schema, template library, etc.
So maybe if you did a master graph using to instantiate GIST, that would give you something that you could use for your data integration.
Right. Yeah. So for me, I'm curious a little bit as well in terms of GIST. I haven't explored it that much yet. I've explored it at the surface, but not into the depth yet. So that is something that I'm looking into. So, and to see the bridge over into the Terminus DB land for GIST and how it interrelates and how it might work. So that will be an interesting thing that comes in the next few months, hopefully. So something like that.
Right.
Which comes a little bit, I think, in the next steps that I wanted to. Yeah, so to enable users with built-in upper ontologies, such as GIST, but I think that there might be others as well that could be relevant. And the idea is to have some kind of a template library for modelers, so that there is an easier interaction between modelers and software engineers. The Git for data, so the GitHub for data that is in beta at the moment. It works for small data products. We know that it works for larger ones, but only in specific environments. So we want to open up that for all kinds of environments. And then to build much more on the data visualization side. The ontology view and the class view that you saw, they were just released last week. So I was happy to finally get them out. And to expose more of the reasoning data log engine so that you can actually do reasoning using a user interface. And I think that is something that is important in this space. So more or less this. I'm happy to connect. So connect with me on Twitter or on LinkedIn or anything if you want to know more, or if you want to go into more details or after the show. So.
No. Thanks.
Yeah, thank you so much.
Any last thoughts here? We've got a couple minutes left, and if not, we'll give everybody a few minutes.
JT, something just came up in the chat. The question just
thank
popped
you.
up in the chat.
is branching only at the data product JSON LD document level or also at the concept level?
Oh, please repeat. Sorry, I wasn't hearing the full.
Yep. Is branching only at the data product level, such JSON LD document, or is it also at the concept level?
It's on both. So you both on the schema class level. So you can have branching on the models. You can have multiple versions of your branch with individual sets. They are connected. So you connect the data level, the instance level, and the model level. They work together. So you get a branch is for both at the same time. It would be hard otherwise. But so you do a branch, and that means that you're branching the model and the data into a separate branch. You can continue working that there fully isolated from everything else until you're satisfied. I don't know if it helps answer the question.
Very good. Got a thumbs up. Excellent. Well, thank you for joining us this month and presenting. I'm going to email out the presentation, everybody, and I'll include your email in there if that works, and folks can contact you that way, and we'll go from there.
Thank you so much for
Excellent.
today, and thank you for the great questions, and let me know if there's anything else.
Yep, very good. Well, thanks all, and we will see you next month.
Thanks a lot. Take care.
Bye.
See you then.
Thanks. Bye.
Bye.